Hello students, this model is on steps in sampling design. Sampling and sample size are crucial issues in pieces of qualitative and quantitative research which seek to make statistically based generalizations from the study results to the wider world. To generalize in this way, it is essential that the sampling method used and the sample size are appropriate. They have to be representative of the population, and that statistics can discern association or differences within the results of a study. Let us look at the definition of some terms. The researcher must keep in mind the following definition of terms while preparing a sample design. Universe. While preparing a sample design, it is foremost required to define the set of objects to be studied. Technically, it is also known as the universe, which can be finite or infinite. In case of a finite universe, the number of items is limited, whereas in an infinite universe, the number of items is limitless. Sampling unit. It is necessary to decide a sampling unit before selecting a sample. It can be a geographical one like a state, a district or a village, or it can be a construction unit like a house or a flat, or it can be a social unit like a family, a club, a school, or even an individual. The source list. In other words, it is called the sampling frame from which the sample is drawn. It comprises the names of all items of a universe, in the case of a finite universe only. If source list or sampling frame is unavailable, the researcher has to prepare it by himself. Sample size. This is the number of items selected from the universe constituting a sample. The sample size should not be too large or too small, but optimum. In other words, an optimum sample accomplishes the requirements of efficiency, representativeness, reliability, and flexibility. Parameters of interest. While determining a sample design, it is required to consider the questions of the specific population parameters of interest. For example, we may like to estimate the proportion of persons with some specific attributes in the population, or we may also like to know some average or other measure concerning the population. Budgetary constraints. Practically, cost considerations have a major impact upon the decisions concerning not only the sample size but also the sample type. In fact, this can even lead to the use of a non-probability sample. Sampling procedure. The researcher at last decides the techniques to be used in selecting the items for the sample. In fact, this technique or procedure stands for the sample design itself. Apparently, such a design should be selected which for a provided sample size and cost has a smaller sampling error. Now we shall see why we need a sample. In some circumstances, it is not necessary to select a sample. If the subjects of our study are very rare, for instance, a disease occurring only 1 in 100,000 children, then you might decide to study every case you can find. More usually, however, you are likely to find yourself in a situation where the potential subjects of your study are much more common and you cannot practically include everybody. For example, a study of everybody in your district who has been diagnosed as suffering from asthma would be impossible. It would take too long and cost too much money. Therefore, it is necessary to find some way of reducing the number of subjects included in the study without biasing the findings in any way. Random sampling is one way of achieving this, and with appropriate statistics, such a study can yield generalizable findings at far lower cost. Samples can also be taken using non-random techniques. The representative sample. It is an explicit or implicit objective of most studies in nutrition and health care which count something or other quantitative studies to offer conclusions that are generalizable. This means that the findings of a study apply to situations other than that of the cases in the study. To give a hypothetical example, Smith and Jones 1997 study of consultation rates in primary care, which was based on data from 5 practices in differing geographic settings, urban, suburban, rural, and so on, finds higher rates in the urban environment. When they wrote it up for publication, Smith and Jones used statistics to claim their findings could be generalized. The differences applied not just to these 5 practices, but also to all practices in the country. For such a claim to be legitimate, technically for the study to possess external validity, the author must persuade us that their sample was not biased, that it was representative. Although other criteria must also be met, for instance, that the design was both appropriate and carried out correctly, the study's internal validity and reliability. It is representativeness of a sample which allows the researcher to generalize the findings of the wider population. If a study has an unrepresentative or biased sample, then it may still have internal validity and reliability, but it will not be generalizable, it will not possess external validity. Consequently, the results of the study will be applicable only to the group under study. It is essential to a study's design, assuming that study wants to generalize and is not simply descriptive of one setting, that sampling is taken seriously. The first part of this module looks at how to gather a representative sample which gives the study external validity and permits valid generalization. However, a second issue must be addressed in relation to sampling, and this is predominantly a question of sample size. Generalization from data to wider population depends upon a kind of statistics that tests inferences or hypotheses. For instance, the t-test can be used to test a hypothesis that there is a difference between two populations based on a sample from each. To give an example, we select 100 males and 100 females and test their body mass index. We find a difference in our samples and wish to agree that the difference found is not an accident due to chance, but reflects an actual difference in the wider population from which the samples were drawn. We use a t-test to see if we can make this claim legitimately. Most people know that the larger a sample size, the more likely it is that a finding of a difference such as this is not due to chance, but really does mean there is a difference between men and women. Many quantitative studies undertaken and published in medical journals do not have a sufficient sample size to adequately test the hypothesis which the study was designed to explore. Such studies are by themselves of little use, and for example, in the case of drug trials, could be dangerous if their findings were generalized. We will consider these issues of sample size and how to calculate an adequate sample size for a study sample, the second half of this module. Steps in sampling design. There are 7 steps involved in this process. The first step is to define the population. It is the aggregate of all the elements defined prior to selection of the sample. It is necessary to define population in terms of the following: the elements, the sampling units, the extent, and the time. Here is a simple example. If we were to conduct a survey on the consumption of tea in Tamil Nadu, then these specifications might be as follows. Element is housewives, sampling unit, household, and then homemakers. Extent is Tamil Nadu, and time from January 1st to 10th of 2017. It may be emphasized that all these 4 specifications must be contained in the designated population Omission of any one of them would render the definition of population incomplete. The second step is to identify the sampling frame. The sampling frame could be a telephone directory, a list of blocks and localities of a city, a map, or any other list consisting of all the sampling units. It may be pointed out that if the frame is incomplete or otherwise defective, sampling will not be able to overcome these shortcomings. The question is, how do we ensure that the frame is perfect and free from any defect? A perfect frame is one where every element appears on the list separately, only once, and nothing else appears on the list. This type of perfect frame would indicate one-to-one correspondence between frame units and sampling units. Nevertheless, such perfect frames are rather rare. Accordingly, one has to use frames with one deficiency or another, but one should ensure that the frame is not too deficient so as to give up altogether. This raises a pertinent question. What are the criteria for a suitable frame? In order to examine the suitability or otherwise of a sampling frame, a number of questions must be asked. These are: does it adequately cover the population to be surveyed? How complete is the frame? Is every unit that should be included represented? Is it accurate? Is the information about each individual unit correct? Does the frame as a whole contain units which no longer exist? Is there any duplication? If so, then the probability of selection is distributed as a unit can enter the sample more than once. Is the frame up to date? It could have met all the criteria when compiled, but well be deficient when it came to be used. This could well be true of any frame involving the human population, as change is taking place continuously. How convenient is it to use? It is readily accessible. Is it arranged in a way suitable for sampling? Can it easily be rearranged so as to enable us to introduce stratification and to undertake multiple stage sampling? These are the demanding criteria, and it is most unlikely that any frame would meet them all. Nevertheless, they are the factors to be borne in mind whenever we undertake random sampling. In social or epidemiological research, most of the frames are from census reports, electoral registers, lists of members, unit of trade and industry associations, lists of members of professional bodies, lists of dwelling units maintained by local bodies, returns from an earlier survey, and large-scale maps. We shall now go on to the third step. Specify the sampling unit. The sampling unit is the basic unit containing the element of the target population. The sampling unit may be different from the element. For example, if one wanted a sample of homemakers, it might be possible to have access to such a sample directly. However, it is easier to select households as a sampling unit and then interview homemakers in each of the households. As mentioned in the preceding step, the sampling frame should be complete and accurate. Otherwise, the selection of the sampling unit might be defective. It is necessary to get a further specification of the sampling unit both in personal interview and in telephone interviews. Thus, in personal interviews, a pertinent question is, of the several persons in a household, who should be interviewed? If the interviews were held during office times, then the heads of the families and other employed persons are away. Interviewing would underrepresent employed persons and overrepresent elderly persons, housewives, and unemployed. In view of these considerations, it is necessary to have a random process of selection of adult residents of each household. One method that could be used for this purpose is to list all the eligible persons living at a particular address and then select one of them. Moving on to the fourth step, specify the sampling method. It indicates how the sample units are selected. One of the most important decisions in this regard is to determine which of the two probability and non-probability sample is to be chosen. In case of a probability sample, The probability or chance of every unit in the population being in the sample is known. Further, the selection of the specific units in the sample depends entirely on chance. No substitution of one unit for another is permissible. This means that no human judgment is involved in the selection of a sample. In contrast, in a non-probability sample, the probability of inclusion of any one unit in the population in the sample is not known. In addition, the selection of units within a sample involves human judgment rather than pure chance. In case of a probability sample, it is possible to measure the sampling error and thereby determine the degree of precision in the estimates with the help of the theory of probability. This theory also enables us to consider from amongst the various possible sample designs the one that will give the maximum information per rupee. This is not possible when a non-probability sample is used. Probability sampling enables us to choose representative sample designs. It also enables us to estimate the extent to which the results based on such a sample are likely to be different from what we would have obtained had we covered the population in our study. Conversely, the use of probability sampling enables us to determine the sample size for a given degree of precision, indicating that our sample results do not differ by more than a specified amount from those yielded by a study covering the entire population. Step 5. Determine the sample size. In other words, one has to decide how many elements of the target population are to be chosen. The question of how large a sample should be is a difficult one. Sample size can be determined by various constraints. For example, the available funding may specify the sample size. When research costs are fixed, a useful rule of thumb is to spend about one half of the total amount of data collection and the other half for data analysis. This constraint influences the sample size as well as the sample design and data collection procedures. In general, the sample size depends on the nature of the analysis to be performed, the desired precision of the estimate one wishes to achieve, the kind and the number of comparisons that will be made, the number of variables that have to be examined simultaneously, and how heterogeneous a universe is sampled. Step 6. Specify the sampling plan. This means that one should indicate how decisions made so far are to be implemented. For example, if a survey of household is to be conducted, a sampling plan should define a household, contain instructions to the interviewer as to how he should take a systematic sample of households, advise him on what he should do when no one is available on his visit to the household, and so on. These are some pertinent issues in a sampling survey to which a sampling plan should provide answers. The final step, select the sample. This is the final step in the sampling process. A good deal of office and field work is involved in actual selection of the sampling elements. In this stage, the problem faced by the interviewer relates to contacting the respondent, who is the sample. Several techniques can be adopted for this purpose. The researcher must be clear on the goals he or she has established for the research work and use the appropriate technique. The following section gives an overview of the types of sampling design. So to conclude this module, we have seen a brief description of the various terminologies in sample design presented above. In every piece of good research, the authenticity of the work lies in the sample. Therefore, sampling must be well planned and executed. Samples must be representative of the population and selected in a stepwise process. At times, several methods of sampling will have to be required in the same study. To conclude, I suggest that an appropriate sampling design is mandatory for research work to be published in a peer-reviewed journal.